In the last video, we talked about just what is a Taylor polynomial and a little bit of how we use it to approximate functions, since polynomials are just easier to evaluate rather than, say, logarithms or trigonometry or inverse trig functions, especially for values that we don't really know the logarithm or trig ratio for off the top of our heads. So we want to find a fourth order Taylor polynomial that approximates y equals 2 times cosine x near x equals pi over 2. So just kind of identifying our pieces, the pi over 2 is our center, which we usually call A. Fourth order means that this is going to be a fourth degree polynomial. So we're going up to a fourth power. So what it is we would be doing is we always start with 0. So I would need the 0 derivative of f, which means I just want f with pi over 2 plugged in, over 0 factorial times x minus pi over 2 to the 0. Then move on to n is 1, which would mean the first derivative with pi over 2 plugged in, over 1 factorial times x minus pi over 2 to the first. Then when n is 2, second derivative of with pi over 2 plugged in, over 2 factorial times x minus pi over 2 to the second. Then n is 3, need the third derivative with pi over 2 plugged in, over 3 factorial times x minus pi over 2 to the third. And then I have to go up to 4, n is 4 because of a fourth degree. I would need the fourth derivative with pi over 2 plugged in, over 4 factorial times x minus pi over 2 to the fourth. Sorry for that bell in the background there. So I can figure out the factorials on my own. The powers are fine how they are. What I really need are all those derivatives. So I need to know f of pi over 2. Well, that would be the cosine, 2 times the cosine of pi over 2, which is going to be 0. I need the first derivative of our function, which would be negative 2 times sine of x. And if I plug pi over 2 in for that, I get negative 2. I need to know the second derivative of our function, which would be negative 2 cosine of x. And when I plug pi over 2 in for that, I'm going to get 0. I need to know the third derivative of our function, which would be 2 sine of x. And when I plug pi over 2 in for that, I get 2. And then I need to know the fourth derivative of our function, which would be 2 cosine of x. And if I plug pi over 2 into that, I get 0 again. And now I can plug these things in. So plugging 0 in here, I would have 0 over 1. And then x minus pi over 2 to the 0 power is 1. Then I have negative 2 over 1 factorial, which is 1, times x minus pi over 2 to the first. Then I have 0. 2 factorial is 2, times x minus pi over 2 to the second. Then third derivative with pi over 2 plugged in. 3 factorial is 6, times x minus pi over 2 to the third. Then 0. 4 factorial is 24, times x minus pi over 2 to the fourth. And I have several terms here with 0 coefficients, so if I go ahead and simplify that a bit, what I get is negative 2 times quantity x minus pi over 2 plus 1/3 times x minus pi over 2 to the third. And this right here is a fourth order Taylor polynomial for 2 times cosine x near x equals pi over 2. So let's say I wanted to estimate what 2 times the cosine of 1.5 is. Well, rather than having to go through, pull out a calculator for it, I can actually just plug 1.5 in for x in this Taylor polynomial, and what I'll get should be very close to the actual function value.